Hello, everybody. As I said, I am coming to you from sunny Detroit, Michigan, at a customer site, and it's funny. It's as warm up here as it is down there, so it's like I'm with y'all. So that's fun. So that's me. I figured I'd change my profile pic up a little bit to have camaraderie with anyone who's at Sabre. That was my badge back in the day. I am currently a senior developer advocate at Snyk, but I started my career at American and moved up through the ranks. I have about 30 years of software development experience. The last decade or so, mainly in the consulting space around dev tooling, dev process, DevOps, build automation, things like that. That's where I got introduced to Docker. I was an early adopter of Docker back in the .6 version, and I've since I am now a Docker captain, which is a group of Docker users who get inside info from Docker Incorporated and get to give them info back from the community. Part of it's like a ambassador type of a thing. I also have certifications in the three usual Kubernetes certs that you see: administrator, application developer, and security. Well, my security one's about to expire. I'm waiting for KubeCon to get a discount ticket to re-up that one. But we'll talk a little bit more about my thoughts on those in a minute, or when we get to the end in the resources. So what are we going to talk about? DevOps and security. Some people think of it as versus, and it shouldn't be that way. We'll kind of level set there, and then we're going to get right into the meat of this, which is what are the challenges developers face when we start containerizing our apps and moving them into Kubernetes or whatever orchestrator you might use, probably Kubernetes. And then really the meat of the talk is going to be demos, showing you some examples of how that can impact you if you're not aware of things or using defaults, and then some ways you can mitigate and head off some of those problems. And we'll get into our conclusions and Q&A and whatever else we get to. So DevOps, we've been doing DevOps for a decade plus, really some of us even longer. And when we think about DevOps, we often think of the SDLC pipeline, the continuous delivery pipeline, because it kind of came around as CD was coming up. And the idea of shifting everything as far left as you can to get fast feedback loops. Usually we would think about this in the goal of build breakages, automated tests, and other things like that. Security, historically, did not get very far left. And I've added our Snyk patch logo, that's Patch the Dog. In the couple of spots we usually saw security applied in the early days of DevOps. And production is kind of obviously you're going to have it in production. You're going to have firewalls around things. You're going to have access control lists. You're going to have all the practices we normally think of when you think of runtime production security. It started getting into our life cycle pipelines when CD really started, when pipelines started becoming a thing, and it was usually late stage. It was something that would happen well into the release cycle. So you would have your whatever your artifacts are, your deployment would get past usually functional testing and at least get most of the way through it before you had an audit would happen. And usually this was a gating step in the pipeline, because it was either manual. You had an appsec team that would do the audit, and if they found a problem, they'd pull the cord, stop the line, and you would get to come to a nice meeting where you had to think back 3-4 weeks what you were doing and how you could have introduced such a horrible vulnerability into or exploitable thing into your code. That's really not great. And if it was automated, often it was late because either the automation that existed was very slow, ran like overnight, and or it was onerously licensed in that you could only run it on a certain number of nodes in your Jenkins cluster or whatever you might be running it in. So you kind of had to queue up and wait for your turn to get to get inspected. As time went on, some security aspects, especially around containers, started to shift left. You started to see, for instance, in the container space, when I push an image to a registry, that registry might have some scanning capabilities as it comes in. And you push it in there, and 15, 20 minutes later, you would get a report. You get a big spreadsheet full of CVEs. And, here you go, hand it off, have fun with that. Put it in the backlog. We'll get to it someday, hopefully. And then I'm going to build the rest of this out. As time went on, things got better and better. Now, Snyk, I'm going to be showing as an example. This is not meant to be a sneak pitch in any way. There are many tools out there for doing container and other kinds of scanning. Our tool was originally written for doing application security scanning for developers on the developer desktop. And so they carried that forward in the container space. So that's why I'll be showing it here. And the idea being you want to be able to get this kind of information quickly, the fast feedback loop. This is where we get into the term DevSecOps. Security has always been part of DevOps. It's just been hard to implement. And we want to get to where we can make sure it's being included. You have Dev QA, Dev whatever ops, DevSec security should be part of that. So what are we talking about when we talk about these container challenges for security with developers? The first and foremost, you've got an increased scope of responsibility. Historically, as a developer, I know that I should be sanitizing inputs on things coming into my code. I should be making sure that the dependencies I add to my builds are from known good sources, and I should be watching for updates and getting updates, updated modules and for vulnerabilities. And if I'm really good at it, I'm looking at my transitive dependencies. I'm fixing that. So our own code, we know to keep that clean. But when you start getting into containerization, you're dealing with what used to be operating system and sometimes infrastructural level scope. You've got things like operating system packages, whether they be APT or RPM or APK or whatever. You've got distributions of what kind of Linux is this base image based on. You've got the choice of a base image. Which one do I need to choose? You've got things like file system permissions issues and user ID, UID permissions and network and storage and all these things that we know about as developers, but in historic times, these were things that were given to us by our sysadmins or our security and storage teams and our networking teams. Well, now a lot of these live right next to our code in Dockerfile or whatever container build system you run. And are you making the right choices in that Dockerfile? Are you making the right choices in your Kubernetes YAML? Are they secure choices? Are there defaults you're not aware of that are opening you up to a poor security posture? Well, this is all pointing to we have a lack of expertise in development world on operating system level security things. We just do. It's not something we were doing for all the time. We were writing apps before containers took over the world. It's just not something we had to think about too much. In fact, this even extends to middleware. So if you're a Java shop and you're running on Tomcat, are you running on, are you keeping track of what version of Tomcat it is? Are you deploying a hardened version of it? Things like that. It's like, that's the middleware team's problem. No, it's everybody's problem, really. And then finally, all of the things you do here, whatever tool you choose, whatever practices and process you put in place, you have to pay attention to velocity. We move to agile iterative development to speed up the time to market. And if you're introducing something that's going to slow that down, it's going to be hard to get business to buy into this cool new tool you found if it's slowing down velocity. So you don't want to do that. And you also don't want to, when security problems happen, ignore them, right? So there's that balance you need to weigh. So when I talk about applications and services and whatever, what do they contain? We mentioned a minute ago, you got your code, the source code of your app. We know we need to write secure code, and there are tools, including ours, that can do that. And we talked about third-party dependencies. This is an example of a Python, PyPy requirements text it's pulling in Flask, but what version? We know that kind of stuff is we need to concern ourselves with. But now we get these Docker files. So if you look at this little snippet, this is a contrived example of a Docker file. And if you're new to Docker, Docker files are kind of that standard definition form for the container image, which is what a container is kind of started from. The file system and some of the environment info for the process that's going to run a container. And here we have Python 3 is the from line. That's the base image. It's like, well, what 3? Which version of 3 was it? What is it? 3.1.5? Is it 3.11.6? What is it? What distribution is it on? What is apt-get? What is stress-ng? What version of that? All of these concerns are what I'm talking about. And of course, on top of that, you've got your IAC. You've got Terraform, for instance. You've got how are we setting up AWS or GCP with our whether it's Terraform or whatever tooling you're using to do that. And then on top of that, you've got Kubernetes, which has YAML upon YAML, and the Helm charts on that, whatever else you're using. And the API is changing 3 times a year, and things are getting deprecated. And are you taking good defaults and blah, 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 blah. It's enough to make you hyperventilate, just getting your app to run well. Nevertheless, not even counting, is it secure? So enough slides. Let's get into a demo to kind of try to visualize this or make this concrete. We level set here real quick. So this demo is going to be of a legacy application that you have that is kind of your, it's the cash cow. It's making money. It's in maintenance mode. We don't do anything to it other than minor fixes every once in a while. But years ago, I'm doing a Java one. I'm a Java developer from the past, so it's a Java app, a JEE app that runs on Tomcat, and we lifted and shifted it into containers years ago, running it on Kubernetes because we wanted to take advantage of the nice packaging that you get from that. And let me show you what it looks like. So this is our big money maker app, copyright 2015, to-do list MVC. This app is, let's see, where is my IDE? I have too many full screen windows. I can't find anything. Sorry, just a second. There's IntelliJ. So this is the Dockerfile. We saw a little snippet before. Again, if you're not familiar with Dockerfiles, these steps are what build out a Docker image. And this happens to be a multi-stage Dockerfile. It has a from line and another from line. Multi-stage means the last stage is going to be what gets built to get published. Every other stage is kind of an intermediate step that you can then use bits of to form the last. Well, I'll show you. We've got Maven 3. We're using this a Maven based application. We're copying in the POM and all the artifacts, the source code, and then we're running Maven install to build our web app. Then in the next phase, we're starting from the official Tomcat image. This is the Apache Tomcat from Docker Hub version 8.5.21. Copy in a bunch of things, some configuration things, and then copy from the build stage the web app, basically the bits of the web app we need for production. So you just put into this what you need in production. So I'm not going to go through the time to build this and deploy it. I've already done that. That's what you saw in the other. Just getting too crazy with my screens. That's what we see here. Now, switch hats. Now I'm the black hat. I am somebody who has a Java background, so I peruse vulnerability things and reports, and I'm sipping coffee one morning looking at the Apache Tomcat vulnerability fix reports, and these are all the things Apache has done to fix security issues in Tomcat through all the versions. And I notice, maybe I'm searching for these, I notice a remote code execution vulnerability. That an RCE, as we call it, is exactly like it sounds. It's a vulnerability that if successfully exploited, allows me to execute code remotely on wherever the application is running usually. Sometimes you hear of arbitrary code executions as a flavor of them as well. So this is interesting because it says it was fixed in 8.5.22. And I'm going to dig in a little. If I go to the CVE, I'm going to go to the Snyk database version of the CVE because it's got a lot of nice added info about things. You can see, it's a pretty severe one. And down here, because it's pretty old, there's a lot of info. I have a lot of Git commits around the fixes, but these exploit DB links are interesting. The first of them is exploit database often has proof of concept code of how to exploit a vulnerability. And sure enough, this is a Python script that can be used in kind of a war driving kind of a thing, where you could just start picking away, looking for sites that might be vulnerable. And I don't really have to do any research on how to exploit this. I can just use this example, and I could look at it and I can see what they're doing in the payload and whatnot. But this script has two functions. One that checks to see if an HTTP endpoint is vulnerable, potentially, and another one to make an exploit out of it. So I've taken that and I've wrapped it in a shell script, or excuse me, an alias actually, here. And imagine this was running overnight, picking away, looking for sites. And I've hard coded this to hit my site just for speed. And it finds one. It says, hey, this site it probably would have been an IP address if it was looping, but looks like it's vulnerable. And so if I come back to my site now, what has happened is I'm actually not interested in my app. I'm not worried about my app. I'm going to put in poc.jsp. See those A's? I guarantee you 30 seconds ago, those weren't there. What this script has done is it has formed a JSP, Java server page, and pushed it to this vulnerable Tomcat server. And the Tomcat server has dutifully taken it, and now it is part of the site. So putting a bunch of A's on a page is not horrible. It's vandalism maybe, but what else could I do? Well, the other side of that script, if I change this now to PWN, now I've got a little form. In this form, I can type any Linux command, and it's going to run it on the Tomcat's remote server. It's basically shelling out and doing whatever I ask it to. So I can say, who am I? I'm root. Oh, that's nice. And that who am I? That host name was interesting. It was kind of a containery looking thing. So let's look at our environment. Look at all this info. Hopefully there's no passwords in here, because you wouldn't send a password into your Tomcat server in an environment variable, would you? I'd know it if you did. This is Kubernetes. So this is running on a Kubernetes server. That is my internal API endpoint for the that's the internal IP address for the API server of the Kubernetes cluster. All sorts of neat information in here. Let's see, what else can I find out? Cat, etc, hosts. Some interesting more information. I wonder. Let's see. Oops. Touch. Etc foo. Now let's do ls ltr. Let's see. And scrolling to the bottom, sure enough, I was able to create a file in the etc directory in this container. So it's a read-write file system. So I could keep going. Oh, another one I like to always check. Let's see, can I do a curl of HTTPS? Let's try 2 T's. HTTPS google.com. 301, that's a valid response. That tells me I have curl at my disposal. And I have internet access because I probably do. I got something returned to 301. It's probably Google. So since I'm root with a read-write file system and internet access, I could probably, let's see. Well, actually, let's do this. Let's see. Okay, standard error doesn't come back in this tool, but I would have gotten something back from nmap. I must not have it. So let's do an apt-get update. And so we see, oh, it looks like I've got apt repository access of some kind. And this tool kind of outputs weird. So this, it's not showing everything, but apt-get install, yes, nmap. And anyone who knows what nmap is, that allows me to start poking around and looking for things on the network that this is running, and maybe looking to expand my exploit, yada yada, go on. Honestly, at this point, I'm probably using curl to download a script that's going to start poking around and do this stuff for me, or I'm installing some kind of crypto miner and I'm going to use as much CPU as this thing has. And because it has as many issues as it has, and it's so old that it has this vulnerability, it's probably also not deployed with CPU limits or memory limits. So I probably have control of the entire node from a resource point of view if I'm going to do some crypto mining. So fun stuff there. So how would I, as a developer, switching back that hat, headed this off before this got to this point? I'm going to jump back to my shell. Kill this. That shell is actually, I just killed it, but that script is kind of cool. It actually opened a reverse shell. I could have just been typing things there. It's formatted kind of funny, so I didn't. But I'm going to cd up a directory. In fact, I'm going to do, this is running out in a cloud server on K3S out in CKAD, which is just a service I like to use. It's, I have the image here locally though, so I'm going to do, let me grab, I've got a ton of images, so I think I've called it to-do list something. Yeah. So this image that the profile pic is the tag on it, don't ask why. That's the image that's running out there. So imagine you're the developer on this and you've got a small bug you're fixing, or you're doing something on it, and you do a little unit testing locally. So you've built the image to run it. And now if I just type Snyk container test, and I'm going to feed it that image. So if I was doing it locally, it probably would have a smaller name, profile pic. And I'm actually going to feed it to the Dockerfile as well, since I have it. That's just a little extra hinting data. Oh shoot, I've got 1Password going here. Let's make sure. Sometimes my 1Password plugin is a little funky. Let me make sure that worked. Oh, Wi-Fi, please work. There we go. So what this is doing now, so the Snyk container scanner is analyzing the image, and container scanners will do this. They'll rip through all of the packages that are installed in the image, and also look for other file-based fingerprints. Different scanners look around for different things. And now since our vulnerability database is pretty huge, we don't download it locally, so it's going out and it's pecking away at it. Saying, hey, here's the bill of materials I formed up from what I saw in this image. Tell me anything that could be problematic here. And I just realized I'm logged into my enterprise account, so I'm going to get a ton of traffic on this one. I've got every bell and whistle turned on. So I'll be scrolling a minute here when this comes back up. But it's going to be looking, again, at operating system packages. It's going to look for known vulnerable jars. You're going to see at the bottom of this log4j, it saw that there's jars in there that have the log4 shell vulnerability in it. So there's a very high visibility warning there. Get really old app. Bunch of stuff here is probably licensing information in here. But I'm going to scroll up to the end of the container summary. Here we go. So this is the end of the container scan itself, not including file system level scans. And we see all these critical vulnerabilities. And this is, this is a problem. Here's info about it. It was fixed in this version, blah, blah, blah. But what's interesting to me, and when I first saw this tool, I liked, is that here's the summary. Your image has 735 issues. The base image where it's starting from are table stakes. We're getting 730, all of those are coming from the base image. And 70 of them are critical and 196 of them are high severity. If I would just upgrade my image, it's saying, hey, if you just go to the .94 version of the same 8.5 Tomcat, I dropped to 38 vulnerabilities, none of them high or critical. And most images are going to have some medium and lows, just because there's stuff that just won't get fixed. They're so low hanging. They're so hard to duplicate or whatever that the open source community just isn't fixing them. But the criticals and highs you do want to definitely care about. It's also telling me some other things that are interesting, like I could upgrade to version 10 of Tomcat. That really doesn't gain me anything security-wise. Or if I wanted to, I could go to Amazon's Corretto build of the JVM and get to zeros. So even if I'm a junior developer and I don't know Docker very well, and I don't know Tomcat very well, I can take this and call over my lead, my architect, go to my pair, whatever, and say, hey, this doesn't, I was just doing a bug fix and I ran a scan and this looks bad. And appsec and whoever can come take a look and say, oh yeah, this is pretty old. We should probably get on the latest version, and then we can take a look at what is left of these vulnerabilities, and we can see if we have compensating controls for them or whatever. I'm not going to go through rebuilding it right now, and just for sake of time, I could change this, rebuild it. If I ran the scan again, we should drop down to 38 vulnerabilities. So I'm not doing anything that's adding anything to it in my build. And that would have stopped this in its tracks, because it just never would have got out there. Now I say that because a lot of time this is what happens. Old applications sit out there and vulnerabilities happen even though you're not checking your code. And because CI is not kicking off to test your builds again and rerun a scanner, you don't know about it. Whereas some tools like ours will actually alert you to that. Or if you have a CI that it needs to run as part of that, you make sure it periodically runs as well, not just when a change happens. So there's another issue in this app I'm going to show you that's not technically container related, but it's something I want to talk about because it addresses, well, it's IAC related, it's Kubernetes related. So I'm going to come back up into the app itself. Oops, that's not what I wanted. If I could type to-do list, there we go. So we'll sign into the app. And so here we go. This is our to-do list app. And I'm going to shrink this window a little so we can see my shell in the background. And I'm going to log the okay, logs, follow, to-do list. Again, this is running out in Civo Cloud in a K3S cluster out in the UK. Just because when I search something, that's the logs coming out of the app. So it's logging searches that are done. Oh, Mun was not there, but mom is. So you're seeing, everything we search for is coming through here. Let me copy something. What if I search for this? I'm going to open another shell. If you're familiar with NC Netcat, this is opening a socket and listening on it, just listening for any traffic coming in. This is another VM, also in the UK, but in a separate instance. It's not related to the Kubernetes cluster. It's just a VM sitting out there. Some spaces here. I'm going to issue this. And if you look, it might be hard to read. The string I'm searching for starts with $, curly brace, and then JNDI LDAP. This is log4shell, what I'm going to show you. This is just a search string, but because it has an interpolated variable in it, log4j is going to evaluate that. If I hit go, you'll see that there's the log. If I come back over here, you see I've got a connection received. I'm now on a shell. I'm in a reverse shell into this server. So I can do all the same things I was doing in the other exploit. This is just a different way of doing it. This one using an application OS, not OS, sorry, an application dependency issue where I've not updated my library for my app itself. The scanner showed me this, but I haven't been watching my scanner, right? So I'm going to leave it at that, and we'll talk about what could we do to mitigate this. This was if you remember log4shell, December 21. It was not technically a 0-day, but it was very close to it. It was so prolifically used. Log4j is used everywhere, and it hit so fast that it was like a 0-day. Everybody was panicking. What do I do? So let's get into some. What do we do about 0 days and 0-day like events like that? Let's go back to the slides. What just happened here, just to kind of level set, we have this Kubernetes, it's a K3S cluster out in Civo in the UK with an app that lives in the to-do list namespace, actually in the default namespace on this one, but whatever. And it's got a service in front of a to-do list pod, and it could have a database behind it. It doesn't in this case, but it could. And we expected the browser through the internet to hit the service, through whatever means, and connect to the pod. What actually happened is when that interpolated string got evaluated by the JVM inside and the log4j code, there was an enhancement put into log4j back in 2013 that said, hey, it would be really cool if we use that JNDI to pull remotes, I think it was for remote configurations from your directory servers from LDAPs. Well, that's great, but it also could be used this way. I reached out to an LDAP server, a nefarious something that talks LDAP of my own, which returned bytecode of my creating, whatever I wanted. That got pulled back in and evaluated, deserialized inside my Tomcat server, and that code said, hey, start a reverse shell to wherever I want. And that's what we saw. Now, I put this slide in here just because this kind of you've probably seen the DevOps infinite loop before, right? This is the idea being you're always getting feedback from production to continuously improve your code so that you can then test, build, release, deploy, and the feedback loop never ends. So the same thing is true of security. Log4j hit, and this other Tomcat thing hit, and you can ask Equifax about this. In 2017, Struts had this kind of a problem. And if you're not paying attention to this infinite loop of, oh, a new vulnerability opened, are we susceptible? Yes, let's get it fixed quickly. Equifax didn't do that, and they from I think it was March to July, they had all that time to update, and they hadn't, and they got bit. They were the breach, I think, was from May to July of 2017 because they weren't updating, and they didn't even know they were being breached. So that's why you got to stay on top of this and make sure you're keeping track of both your operating system and your application vulnerability updates. But how would you protect against this if there is no CVE? There is nothing in the vuln databases yet because it is truly a 0-day, or it's so new that they haven't solidified it, and you're in the couple of days of the fog. Well, there's defense in depth. There's things you can practice to help mitigate and slow the hackers down. First of all, on your image front, on your Docker images, you want to minimize the footprint. There is no reason my to-do list app should have curl in it. And a number of other things that's in it. And a lot of that's because I chose the general Tomcat official image. There are other versions of images like the slim images, which take a lot of that extra stuff out. If your business application that you're writing doesn't need curl, don't have it in there. In fact, curl had its own 0-day just a month and a half ago. So don't give hackers the tools to expand their exploits. Understand how layers are working in containers, so layers build on top of layers. That kind of ties into this. Make sure that you're building very tight, small images. Take a look at other things like ChainGuard's got some really cool images out there that are very small. They're kind of like the distroless images. Distroless is another thing you can look at. Lots of tools, lots of things you can look into there, and we can get into it in Q&A if you want. There are different ways to build your images. So I was using a strategy called multi-stage, which is something built into Docker's build tools. There are other tools to build your images, though. Things like, for Java, I'm a fan of Jib, which is another Google open source project that is a 100% JVM-based OCI image creation plugin for Maven, Gradle, or standalone that will create an image. You don't even have to have a container runtime to do it. It's really nice. And it does it with best practice as determined by the open source community. If you're a Go development shop, Ko, K-O, like K like Kubernetes. Ko is a great tool that does that kind of a thing and more. And other things. There's tons of topics here, but just make sure you're practicing. Don't just write a Docker file and be done with it. Run a linter on it. Make sure you're doing good practice. Yeah. So, and then giant topic. Their entire conferences on secure supply chain. When I bring it up here, what I'm talking about is just mainly know where your images are coming from. Don't be pulling images off of public Docker Hub sites if you don't guarantee, you can't be guaranteed what's in them. Don't pull them. Use a managed repository. Any large company of any size should be using a managed registry of images. That could be, if you're on-prem, that could be something like Harbor or one of the vendors that has them. If you're in a cloud, I think Sabre you said you're moving to Google, so GAR would be a great choice there. If you're on Amazon, you've got ECR, so forth. Use a managed registry that you control access to, and the images that are getting pushed into that registry need to come from automated tools, not from Eric. I shouldn't be typing Docker build and then Docker push and have that go anywhere we care about, because I'm not auditable, really. I mean, kind of am, but not really. Whereas your Argo server or whatever you're using to build your things is totally auditable. There's a lot more here we could talk about as far as SBOMs and Vex and all the other technologies that are coming up to help audit and provide chain of custody trail and everything. That's a huge, bigger topic that we can get into tonight. But just make sure you know where your images are coming from. Now, at runtime, this is where we kind of get into where the rubber meets the road. Don't run as root. There is no reason that Tomcat and most e-commerce apps or anything like that needs to run as root. And the only reason the open source official images are root is because that's the default. Most of them come with a non-privileged user that you can change to at runtime, whether it be through a user line in your Docker file, or probably more appropriately in your Kubernetes YAML for near security context. And you see why. Even though I'm in a container, I'm still elevated privilege, and I can do things in that container as UID 0. And heaven forbid I get a breakout, like somebody has bind mounts a volume into it. I'm UID 0 in that bind mount now, and I can read and write whatever I want as on the file system of the host. So things like that. You don't need to be root, don't be it. Privileged containers, this is kind of a no-brainer. Privilege gives you host level access to devices. I actually was talking with Jerome Pederzoni a little bit over a year ago. He is the Docker.cloud engineer that was one of the ones who wrote privileged, and they actually talked about making it be, instead of on the Docker command line -- privileged, they talked about making it -- insecure. because that's what it is. It's the only things that should be running in that mode are generally very low level things like your monitoring tools or your like a network plugin or something. Your app definitely doesn't need it, so don't. Pay attention also to the allow privileged escalation flag in the security context. That is a flag that restricts, if you set it correctly, the ability to sudo, to elevate privilege. And most of your apps don't need that either. Unfortunately, the default is to allow it. So if somebody were to get into a cluster and then be able to run their own image in it, if they had root in it, they might not be able to run if you've got PSA turned on to stop this, but if they can get a SUID on there and you've enabled and you've not set this correctly, you could get a root through other means. So anyway, Linux capabilities, drop them all. If your app doesn't need to be making system calls into the kernel that are generally pretty low level, most business apps don't. Drop them. If you're not sure, you can use tools like Tracy and strace and whatnot and talk to your Linux admins. They can help you out. Read-only root file system. This is one of my favorites because it's simple and nobody does it. This is a way when a container engine, runtime engine starts up a container, a process in a container, it takes the layers from the image, does the work to create the file system for the process, and then it slaps a read-write layer on top of that logically. And the process then, when it makes mutations to the file system, it does that in the read-write layer. So it does a copy on write if you modify a file, or it does inserts the files into that read-write layer. If you run the engine, the container in read-only mode, it doesn't insert that layer, and the entire volume is the root file system is mounted read-only. It's not a silver bullet, but it does make life hard for the hacker because I can no longer then install new tools, curl things. Even if curl is in there, it's very hard where I'm going to put things. I have to make a RAM disk or something. It slows you down. It slows them down. Also, immutability is one of the 12 factors. So if you're writing good small microservice type architecture, if your service is immutable, it makes it easy for the orchestrator to schedule. So if a node's going to go down, it can easily move a stateless service around, as opposed to, or pod, I should say, as opposed to if it's got state, you're probably going to have to have some kind of operator to handle moving that state around with it. So be immutable if you can. So there's that. And then again, deploy from known sources, same kind of a discussion as before. Don't be pulling from random registries. You can restrict that through various means. This gets us into the Kubernetes aspect of this. There's a few things that kind of the low-hanging fruit when you're doing Kubernetes deployments. Secrets, use them. Do not put credentials in environment variables. In fact, if you're using secrets, I highly recommend you don't mount them as in vars, because as you can see, if I get in, I can probably see them, but that's a side topic. But use secrets. Don't put credentials in config maps, because that's just not the way where they go. For goodness sake, don't put them in your Docker image. Don't put them on files that you are going to mount in. Use secrets. If you already have a secret store that you're using, like applications are talking to Vault or CyberArk, the cloud, secret providers, continue to use them. They're great. It's wonderful. If you already have expertise in monitoring around that, wonderful. Kubernetes secrets are like config maps. They have their own custom types, but they are separately RBACable. Right, you can set up different RBAC for the secret than you would for a config map, and you can really nail down only these service accounts should have access to these things. Right, set that all up. You can also, if you are a cluster admin, if you are using Kubernetes secrets, if you're deploying your own Kubernetes clusters, make sure you're encrypting them at rest. The etcd store does not encrypt them by default. If you just do kubeadm install, stand up a cluster, they're just going to be base 64 text in etcd, and that's not encrypted. I mentioned RBAC. Use it. Don't have much more to say about that. It can have a learning curve, but you need to learn it. It's important. You need to restrict access to things based on role. Period. Security context. This is the API on the pod and containers that implements much of what we saw on the prior slide and other things. It's surprising how big pods and deployments where they're not really specifying it. It's going away as other enforcement tools come in, which we'll talk about in a minute. But learn it, use it, and then finally, I'm going to sit for a minute on network policy. So I mentioned in the Log4j example that there are things. There's I brought it up for a reason, even though it wasn't a container exploit. One of the reasons why you could get around, or that worked, was because there was willy-nilly, there was no security on that Kubernetes cluster. There was nothing, that namespace was wide open. By default, a Kubernetes cluster with a CNI in it, any pod can talk to any other pod in the cluster without NAT. And network policy is where you restrict that. And I'm a fan of starting with zero trust. No pod can talk to anything. Now, when I bring up network policy, most developers kind of start to get, oh, that's firewalling. That's not me. That's the network team. That's the security team. We open requests. That's perimeter firewalls. That's not what I'm talking about. Network policy is a stateful way of telling Kubernetes that in this namespace, this is how I want things to be allowed to or not allowed to talk to each other. And if you start from a zero trust point of view of like nothing can talk to anything except DNS, you got to have DNS. Always got to have DNS, but nothing can talk to anything. And now I simply allow just the things I need. So in our example, with the log4j example, we had the service, and maybe let's say we had a backend and a database. I would say the service can take, the pod can take outbound, external traffic in on port 8000 or whatever. That's it. And then the backend can take traffic from the front end on this port. And then the database can be contacted this direction. And I'm probably going off camera, sorry. Those are the only things now that I can do. And even if I got into a front end cluster pod, and started running Nmap around, Nmap's going to be blocked everywhere it tries to go because the Kubernetes CNI plugin is going to be doing whatever it does to disallow that traffic. So if I'm trying to poke away and find another copy of the app that maybe is not protected very well, I can't if I can't get to it, right? So network policy is your friend. Don't be scared of it. Learn it, love it. And in the case of Log4Shell, if I had implemented a zero trust thing, that turns from a remote code execution exploit to maybe a denial of service, because the Tomcat servers might start thread building up as those connections are hanging on the network policy firewalls. But denial of service is better than somebody walking around with a shell inside your cluster. So enforcement, all of these things I'm talking about, you want to make sure people are doing them, and admission controllers in Kubernetes are generally the way you do this. And there's OPA with gatekeeper admission, there's Kyverno is another popular one, and of course there's pod security admission, which is kind of the replacement for the deprecated and removed pod security policies. But it's really easy. It's nice. You can just say this namespace is restricted, and all of a sudden a lot of the things we just talked about just get enforced. I can no longer deploy a pod that is going to start a container as root, and all sorts of other things. So look into those. So key takeaways as we're approaching time. The feedback loop. This all goes back to DevOps and Agile. We want fast feedback. You want to know quickly when things are vulnerable, when a new vulnerability comes up, even if you haven't touched the code. And you want the information about those vulnerabilities or risks to empower developers. You want a tool that helps you gives you proactive information so that you can be a player in the security space, not a subject of it. You don't want security bashing you over the head with a list of CVEs. You want to actually be like, hey, this looks bad, let's talk. And security will love you for that. And finally, practice defense in depth. This is always a good security play, and do things that make life hard for the hacker, so that if there is a 0-day or some kind of thing that you haven't updated yet, it's going to be harder for them to take advantage of it, and they're going to move on to an easier target somewhere else. So I know this is an eye chart of things. I'm going to make a PDF of these slides and have Jim just, I'll give it out to you guys however that works. But there's a bunch of things here that you might be interested in. I mentioned the CNCF certifications, the CKAD, which is the application developer certification, and the CKS, which is the security specialist certifications, are probably the most applicable to this topic. I love the CK star certifications because they're not just multiple choice tests. And I'm not a CNCF ambassador. I don't work for them. I'm not just trying to shill for them. But what I like about them is that when you take these tests, you're given a cluster, you have to change context to it, and you have to make that cluster be what they're telling you to make it be, or you have to fix the problem in it with the application. You have to do things in it. It's really hard, but you learn a ton. Just even if you don't get the cert, take the trainings. There's tons of classes and books out there on these. Most of them are excellent, and you will learn more studying for a CK star cert than you will doing most of anything else, honestly. Nothing beats working on it in practice. But anyway, I've been talking a lot. I'm gonna kill my screen share.
All right.
And see what we got in chat.
Yeah, and as far as the slides, yeah, we'll collect those. I'll process the presentation into a video. On our event page, we'll have the video and the slides, so you guys can find those. Usually have them up by the Monday, after the session. Sometimes before. Well, there's a couple of World Series games coming up for the Texas Rangers, so it might might cut into my processing time. Yeah, there. You did show some nice links. We'll have those links in the presentation. And it was right along the lines of a question that Samina had in the chat. Is there? I didn't memorize the whole list, but was there a good book on these security topics for Kubernetes that you would recommend?
Not a single book, but there's an excellent book. There's a couple books that come to mind. There is Production Kubernetes by Josh Rosso and a bunch of other people that were at VMware Tanzu a couple years ago. It's a big book. It's a good reference book. And they go into a lot of security things. They go into both from an operational and an application developer user kind of point of view, just good practice for Kubernetes, which includes security. Liz Rice has a book on, the title is escaping me. It's a container security type book. I'll find it and I'll include it in the slides.
Okay,
it's a short book. It's a good one. And those are the first two that come to mind. There's also, as I was saying, the CK, the certified Kubernetes resources for learning it. Yeah. There's a few. Code Cloud has a lot of good training courses. I'm in a Kubernetes book club, and we're going through a CKA book right now. In fact, I'm leading the talk this week on the networking chapter. Okay. It's by Chad. I should know Chad's last name. He's a friend. But those are the ones that come to mind first. I'll include more in the references if I think of them.
It was his last name's just encrypted right now, so.
Yeah, he doesn't use base64. He's good. Chad Crowell, thank you. Thank you, Raj. Yes. He's going to kill me if he hears about that. Don't tell him I forgot his last name. I just saw him, too.
On this one's more of a Snyk question from Mohammed. Does Snyk have a feature where it can mark vulnerabilities or present a report directly in the source of truth like Git? Like it'll run the analysis and then do a pull request?
Yeah, I don't want to turn this into a sneak pitch, but yes, it can. There's a way to have it be watching your repositories, and it's like if you've got a Git repository, if it sees a Docker file needs a new base image, you can, if you want it to, it will open a pull request and put a new from line in there. You wake up in the morning, you get a nicely formatted pull request that has that. It does it for other things too. There's also, yeah, it does. And there's also one of the things I've used in the past is this is true of most scanners. If you have it as part of your pull request CI process as a test, like an automated test, you can output that in a format that GitHub or whatever you're using could ingest and put it into its own reporting. So GitHub supports serif format. And so you can run Snyk container test, blah, 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 -- output equals serif or something along those lines, don't quote me. And then mark that as an ingest for your GitHub action, and it'll pull it into the security tab in your repository.
Cool. And our friend Ramji is like, what does Snyk stand for? I know he knows. He knows. I know he knows. But
if this was in person, I would have asked that and had swag to give out.
Yeah.
Does anyone? It's the dog. Well, the dog is Patch. So the dog's name is Patch. He's a Doberman. He or she. Actually, that's a good question. I should ask our people, I don't know if it's a he or she.
Oh.
If you're at KubeCon, by the way, anyone coming to KubeCon, we will have the little plush patches. They're like, everyone wants plush patch. We'll have trading machine. Come see me. If you tell me you're on this meetup, maybe I can get you one if you can't get one with the cloth. But anyway, Snyk is an acronym. It stands for So Now You Know. And the idea being, it's not the buildup isn't great, but the idea being, it's a tool that if you're as a developer, you might not know about these things, and by running it, you do.
Yeah.
So I blame our founder guy. He came up with it. But
it's
and it is pronounced Snyk.
Yeah.
According to him.
Snyk. And you really had me freaked out there for a while, seeing exploits in the wild. Just how, I mean, you've practiced this, this as your profession, but it didn't look like it's that too hard. Just go to a few places. You didn't have to know a lot of stuff, and now you get a little page and exploiting it.
There's a YouTuber that we do a lot with, John Hammond, that he you watch some of these YouTubers that are like professional security researchers and white hats, and you're like, oh my gosh. In fact, I don't have it with me, Duffy Cooley, who's a CNCF ambassador that's a friend of mine. He has a sticker he gives out at KubeCon, which is this big, and it's a one-line, I'm not going to put my screen share back on. It's a one-line admin control of your cluster if you don't have things set correctly. It basically starts up and it fires up a privileged container, and then once I have a privileged container, I can own you, basically. So.
All right, and looks like we run out of questions in the chat, but I always save one question last. A non-technical question for all our presenters. It's kind of a career advice question in case we have any kind of younger people in their career on today. Like knowing what you know now, obviously well-experienced technologists. If you could talk to your 20-year-old self, is there any kind of advice that you would give to either a younger you or a younger person entering into technology?
Wow. That's a heavy question. I would say the first thing that comes to mind, and this is going to be, I don't know if this is going to sound weird, but is like, I would tell myself, it's okay to not know things. It is in fact better to not be the person in the room that knows everything, because in fact, this hit me when paired programming, when XP hit. I was like, oh, I would never want to pair program. I would never want to do that until I did it, and I did it with somebody more senior to me. And I had, at the time, was probably a 15-year software developer. I'd done C, C++, which we're all arrogant for C++ coders because we think we know it all because we can handle pointers. But I was doing work with somebody from ThoughtWorks that I highly respect, and she was an amazing coder. And I sat there at the end of that, and I was like, oh my gosh, I just learned more in this 4-hour coding session than probably the last year of reading books or reading blogs or whatever else. So find people who know more than you and look at what they do. I know with remote programming or remote work now, it's harder to do paired programming.
Yep.
But if you have an opportunity to just attend a code review with somebody who's senior and just learn from them, that would be. I was very tunnel visioned as I want to know how to do it myself because I want to make sure that I'm But no, better to not know and learn all the time.
Cool. Well, that's awesome. And there's, I guess, one final super easy question came in from the chat. Samara's wondering how long you've been in IT. What would you say? What's your tenure?
Professionally, I started software development for money in 1993. American Airlines moved me to Texas to be a developer on their clients for their reservation systems for the reservation agents. Before that, I'm a second generation software developer. My dad was a 1950s and 60s punch card programming, Honeywell mainframe programmer. And I picked up the bug, and back in the early days, 8-bit days, I've been coding since I was 12.
Wow.
So it's just one of those things I've been doing forever. But professionally, and like, how long have I been doing it well? couple days.
Just getting into my own stride right about now.
Well, every time you think you know everything, all of a sudden somebody better than you. Like I said, you're always learning.
Yeah.
I have a colleague named Brian Vermeer. He's a Java champion, and oh my God, I was on a call just the other day with him, and I was trying to learn how to do something in TypeScript and I said, you know, in Java how you do it this way, and Brian's like, we haven't done it that way in like a decade, dude. Don't let me. Wow, he was teasing me, but yeah, it's so you're always learning. And yeah, don't get attached to a language.
Right.
Because there'll always be the next best language.
Always the next best thing. Well, Eric, thank you